Okay, video call is being recorded. So I threw together a few slides on Git. I didn't know what to call this. I kind of wanted to call it Git Fundamentals at first, but Git Workshop, I don't know, something like that. Oops, I didn't mean to resize the window. Don't know if that showed up. So as usual, I'll just go through the slides. There's only a few of us here, so feel free to interrupt with any questions. I'm guessing I have like 20 to 25 minutes of slides, so there will be plenty of time for questions and answers afterwards. Anyway, so my background with Git, I had to like think back a few jobs. When did I start using Git? It's probably about 2009. And that was in a professional context for what it's worth, not so much like, oh, I'm just dabbling with these interesting tools that people are talking about. So 2009, that's 13 years ago. I've run into most, you can never say all, but run into most of the regular weird Git situations where you've got a merge that didn't go right, or you're in the middle of a rebase that isn't going right. I've been there for many cases of that kind of thing. Git Bisect is one of the really cool tools built into Git. I'll talk a little bit more about that. But one of the really nice points about source control, you've got the whole history in front of you. So if you know that something used to work and suddenly it doesn't, and you haven't checked it in a month, it's actually pretty easy in Git to go find when it stopped working or when it started working. I am in the Git authors officially in 2019. I got 2 doc fixes in there. So technically I didn't, change any source code, but there's my name's in the history there, which is cool. And before I joined Peggy JV / Strangelove, I was doing a lot of work on some low-level Git automation for a whole system we had for continuous delivery. The problem we were trying to solve there was the so-called not rocket science rule of software engineering, which says that you should test the commit that's actually going to be on your master or main branch. The problem that we were running into at the like 70 to 100 engineer count working on a particular mono repo there was my pull request is green, your pull request is green. I merge mine first, everything's good. You click merge on your green pull request, and now master is failing, or there's a merge conflict. I guess GitHub wouldn't let you do wouldn't let you merge if there was a merge conflict, but tests don't pass or the code doesn't compile suddenly. So we had to do some work to stop that from happening. And my biggest Git pet peeve is when people commit binaries to repositories. It bloats the repo. It's never useful to anybody. The bloat slows down clone times. It can occasionally show up weird in things like Gitgrep. But we will talk a little bit more about one way to avoid that. So what is source control anyways? I was thinking back to like, what did I do? What did anybody do before we had source control? And, maybe it was in college, maybe it was like, side project. You probably ended up with, maybe you're working on like some little website in PHP or something. And you're like, oh, okay, my website works right now. I'm going to go take a zip file of everything and work on it for another day or a couple hours and do a new backup. I searched pretty hard on the internet to find a nice picture of a directory of zip files. Yeah, named like backup 1, backup 2. It's hard to find, but I found something here. And then naming them ends up being so difficult too. You end up with, backup 1, copy of backup 1, start throwing the date on there. So obviously we can do better. We do better than collection of zip files for that. So, what is source control? Maybe it's a set of files in the history with them too. It's probably a little bit more than, at least a little bit more than that if you want to include authorship, but something like that, in my opinion. So I think what I alluded to, I guess it would have been Monday, is that Git is a database, and I think as people who are new to source control coming to Git, there's a million cheat sheets out there. They just tell you, yeah, just run git commit, run git add, and you'll be good. And occasionally you have to git push, and occasionally you have to git pull. That certainly somewhat covers the command line interface, but I think it doesn't help you build a mental model of what's actually going on under the hood in Git. So this isn't actually everything that's potentially in the Git database. I don't have tags on here. There's at least there's notes. There are a few other things that you don't necessarily run into on a daily basis here, but Git has blobs. Those are just files. Over on the right side, version 2, new file, version 1, there's some hash associated with that. I think Git is still on SHA-1, but they're like working on support for SHA-256 because of collisions or something. So, the cryptographic integrity there is, there's probably some overlap with blockchain on that, but it's proof that the Git database has not been tampered with in a lot of ways. So on top of blobs, you have trees, and a tree is basically a directory. So a tree can have blobs in its own directory, and it can have other trees as well there. And then a commit is a reference to a root tree, and it references one or more parent commits, except for the initial commit, which doesn't have a parent, of course. And there's metadata for the authorship. So that's your commit message, commit and author, name and email, and commit and author, author and committer timestamps as well. So that's kind of all there is to it in Git under the hood, aside from a few things that are not super important here. We're going to come back to that closer to the end of the talk, but understanding those few basic objects here, I think, hopefully puts a lot of the commands in a little bit of a new light. And one thing that I think may be surprising, if you aren't aware of those objects in there, is that there is no diff stored in Git. As far as I know anyway, the diffs are all computed on the fly. So when you're doing Git log, you're looking at the diff in a particular commit, or whether you're running some other command to see the difference between different files at different points in time. The diff is always computed on the fly. And I think there have been other version control systems that actually did store just the diffs, and I'm sure plenty of things went wrong in those. So there was a specific request on rebase versus merge. So got a few things to say over here. I've got two screenshots of TIG is my favorite Git related command line tool. It's a little visualizer for Git history. On the left is the Git history for the Go programming language source repository, and on the right is the Git history of the Git project. And the little blue dots running in a nice straight line, okay, you can see my cursor, give us this nice linear, clear history that's pretty easy to follow. And then on the other hand, for the Git repo, there's just merges, lots of individual commits all being merged together. So there's some trade-offs there, and we will talk about those next. I probably should have put some subheadings on these rebase versus merge titles, but this is my mental model of what actually happens when you do a rebase versus a merge. And I guess I probably should have also clarified back on this slide that effectively the Git history for the Go project, ooh, I just accidentally scrolled and changed the page. The Git history for the Go project is effectively a set of rebased commits, whereas on the right, the Git project is a lot of plain old merges. So a rebase whether you're doing a rebase or a merge, there's going to be a common base commit between the branch that you're working on and the target branch. In both cases, you're probably merging or rebasing onto the main branch. So in either case, you start off, Git will find the common commit between your branch and the target branch. And then in the rebase case, however many commits you have on your branch get replayed effectively in sequence over the new commit, which has some trade-offs. And then on the plain merge case, you can merge more than two branches together at once. It's not common, but it is well supported in Git. So Git will look at the resulting trees. So they're effectively going to look at what the diff would be for each of the branches, and it's going to attempt to take a union of all those trees. And you're either going to get a new successful commit out of that, or there's going to be a merge conflict to resolve. So I think rebases tend to be easier to follow because you're replaying a sequence of commits. If there are any merge conflicts, they're going to have to be handled potentially multiple times. Whereas in a plain merge, you typically resolve the conflicts once at the end when you're actually attempting to merge. To update a rebase branch, you have to force push, which of course has its own other set of trade-offs there. It's nice that your history stays clean, but it also can be annoying for other people who are watching your branch. They don't necessarily get to see what changed in history. The GitHub UI at least will just say, oh, they force pushed from commit A to commit B. And you might be able to dig in to find out where it was, but it kind of hides some of the history, which is good in some circumstances and is bad in others. And if you're rebasing, you probably want to rebase early, often, frequently, so that rebasing early and often helps you avoid upcoming merge conflicts. Because the next time you rebase, hopefully you are rebasing on fewer new commits. So that's some of the mechanical trade-offs. When I like to do one versus the other, rebasing is good before you've actually opened a finalized pull request, but especially once you have a PR that has actually been reviewed, I generally prefer to merge main into the pull request, and that's largely an artifact of the GitHub pull request review UI. When you do a force push, the UI doesn't clearly tell the reviewer what has changed since the last time they viewed. And when you do a merge commit, it's a bit more friendly on that. And there are sometimes, somewhat frequently, I would say too, where I'm working on multiple feature branches that are intended to work together, but are somewhat independent. And I just want to get ahead of opening a few pull requests, or I'm waiting on reviews. I will just make a branch name temp or temp1, whatever the case might be, and merge them together so I can continue building whatever it is I'm working on. But usually I reach for rebase, is the takeaway there. And then as far as delivering code between the two, GitHub does give you a few options. I think most, if not all, the Strangelove repos are only enabling squash and merge. As far as merging pull requests, there's also, you can also choose rebase, which would retain all the individual commits. Squash and merge, like it sounds, you might have a pull request with 10 commits, but it will show up as a single new commit on top of the main branch. So I think what's interesting about the plain merge is that you are not hiding any of the original history with a plain merge. So if I push a commit and it has SHA ABC, if I do squash and merge, it's going to get some totally new random, well, deterministic, but effectively random SHA once it's been squashed and merged, because there's going to be a timestamp that I am not able to predict. And there could be some cases, maybe in some industries, where, for example, if you did have a GPG signature associated with a particular commit, doing a squash and merge would result in a new SHA, which would somewhat invalidate the authenticity of the signature in that case. So
I think question on that.
Go ahead.
Hey, so like what we do a lot on the inf side with like Terraform modules, we sometimes reference the commit hash for the module. Are you saying this would impact that kind of process?
If it's a commit hash that's already on a main branch, then typically that would be fine. And I think the way GitHub works is even if it was a commit on a pull request and they eventually did a squash and merge, I think GitHub keeps those individual commits accessible after the fact, but it could be difficult to get at that commit under some circumstances later. If GitHub did do some kind of pruning after maybe a year, I don't know if they literally keep them forever or if those commits expire eventually. But typically, for most projects, once a commit reaches the main or master branch, it tends to stay there forever.
Gotcha. All right, thanks.
Yeah. So I think for some of those high-profile projects like the Git source tree or like the Linux source tree, even though the history becomes more difficult to follow that way, it is a little bit more honest with everyone if somebody emails their patch and says, you know, I just pushed commit ABC123 to my branch and this fixes this driver issue on this particular hardware. It's a little bit more important, I think, in that sort of ecosystem that somebody else can say, oh, they said they pushed commit ABC123. It's right there in the history. Nobody rebased it. It's authentic. And then just the trade-off is if you're trying to inspect the history later with all the merges, it can be a little bit more challenging. That's all I had on rebases and merges. If there's any questions, feel free to interrupt. We'll have more time for questions at the end. Otherwise, I'll go into some of the. Go ahead.
I've always heard rebasing is, yeah, you're rewriting history. Does it, when it replays commits, it's a brand new commit, right? Because I think cherry picking does the same thing.
Yeah. Yeah. So if we go back to, oh, nice little pop up here.
Oh, that's cool.
Yeah. So when you do a rebase, you're going to end up with some kind of new tree object at some point, because you're adding a file, you're changing a file, or removing a file. So at some point, some tree might be the same, some tree might be different. And because the commit SHA is a cryptographic hash of all the commit metadata plus a single tree, it is a new commit object in the Git database. But also, like, you could imagine a situation where you have a branch that's built off of master, and there's two new commits that come in. Somebody makes a change and they revert that change. So the two new commits on master would end up being, you'd have tree with ID 1 would say be the first commit on main there. Somebody, they push a new commit with tree ID 2, they revert it. The tree is the same as it used to be, so it's going to be tree ID 1 again. So like your rebase in that case would be built on that fixed tree ID, but it would have a parent commit with a different ID, and there'd be some different timestamps involved. So, so when people talk about rewriting history, that in the context of a rebase, it really is more about the commit objects than it is. I guess like that's what they mean with history there. So, like you're still going to have the same set of blobs contained in the Git database, but there's just going to be different trees and different commits referencing those trees.
This might be similar to what Nick's just asked, but sometimes I need to hear it twice for it to really sink into my head.
Sure thing.
But when it comes to like auditing and like security kind of stuff, like say that like someone accidentally committed like a key to Git or something, is there any concern about like using rebasing to like mess up the audit trail of like who to blame for that kind of stuff, or to see that that event happened, who actually really did it, when it really happened?
Yeah, there's definitely some, there could be some causes for concern there. So I believe the guidance would be that if you had only committed locally and you didn't push to a remote server, you should be fine to just rebase away, because Git is designed to not push unnecessary objects, unnecessary blobs from your local repository to a remote repository. But as soon as you have a branch that has that in history, I guess there could be a chance that you might inadvertently push that branch out. So if you have it rebased locally, like you're going to end up with so let's say you accidentally commit your AWS secrets and whatever you named it in test.txt, and you actually Git committed it. So you are going to have that blob in your local Git database. And then you're like, oh, whoops, I totally messed that up. You remove it, you amend the commit. So now your new tree is no longer referencing that blob. Nothing is referencing that blob, in fact. The blob will eventually be garbage collected from Git, which means it'll actually be removed from disk. But there is going to be some period of time where that secret has been committed, has been written to disk, at least on, hopefully only, in that case, only to your machine. And so I think there's probably a common novice mistake where somebody might go through that workflow. They're like, oh, whoops, I didn't mean to commit my AWS keys. I'm just going to remove that file and create a new commit, and we're good. And they just don't have a good understanding of, like, it's trivial for anybody to go look at the previous commit and see that, oh, aws.txt has these fun secrets that I can go use to go mine some Bitcoin. So rebasing is not a full answer there. I understand
best practices are to like rotate keys when you do something like that. But are there any best practices on the Git side? Like when that kind of stuff happens, like should just be like, oh, it's a compromised key. Like we shouldn't try to like recreate this repo again, kind of thing.
Once it's been pushed, I would say definitely just assume it is compromised. So it is possible too that you could, it's maybe just some like little toy private repo you've committed and pushed your AWS secrets on accident, and you're like, oh, that's fine. I'll just delete the secret file and I'll just force push to main. At that point, GitHub probably still has the old tree, even though there's no branch referencing it. They have the old tree that points at the old secrets.txt. So there may be a way where you can use the like kind of lower level GitHub REST API to say, show me the content of tree D83, and somebody could see, oh, there it is, secrets.txt. I can go spin up some AWS instances. But even if that didn't happen, it's trivial for people to set up watches on GitHub repos. Like, granted, if this is your little private unstarred thing that you started today, like probably nobody's watching it, but I don't know what the GitHub public fire hose looks like. It's just one of those things that if it's been pushed, you should assume it's been compromised. And I think there's even some tools out there. Yeah, Greco says contact GitHub customer support. Yeah, good idea. Good to still do that. But still assume that the secret has been exposed. But it could be a secret that you can't trivially or quickly roll over either, in which case definitely reaching out to GitHub support would be a good step to take regardless. So I think there are some tools out there that scan GitHub repos and they look for things that look like secrets. I don't remember what the constant prefix is on AWS keys. It's like starts with AKI and has to be so many characters long. So like you can run those against GitHub. I am sure there's integrations that you could run locally just as a pre-commit hook to warn or prevent a commit that contains something looking like certainly a secret formatted in certain ways.
Got it. Cool. Well, thanks for explaining that again.
Definitely. Okay, so going through some of the commands I use every day. Git add -p. I think this was a big level up for me when somebody taught me about git add -p. So chances are you've run into git add by itself. -p is shorthand for -- interactive, and this gives you a nice little prompt, chunk by chunk, or I guess maybe it's a hunk according to that little stages hunk question at the bottom. And you're able to answer yes, no, or everything in this file, skip this file. I really like this because it forces me to look over my change one more time before I actually commit it. And if you're using git add -p, this is how you will probably never accidentally commit a binary file again. It's the git add dot that people pick up from cheat sheets or wherever that results in people committing things that they didn't mean to commit. So git add -p might be the most frequent Git command I use. Might be git checkout. Git Commit Dash V. I'm sure everybody's heard of Git Commit, but the -v flag is probably my favorite there, and that is just, I think, short for verbose. And in the commit, in the editor that it opens, it just shows you the diff down at the bottom after all the other boilerplate in there. So that's helpful for me. Sometimes if I don't remember the name of a function that I wrote in here and I need to mention it in the commit message, it's right there. It's in my Vim autocomplete. And if you miss some context on a larger commit, it's nice to just be in your editor already and be able to scan down there for the diff. Git Fetch -p, Git Fetch and Git Fetch -p. So it's been a while since I've paired with anyone working through moving around branches. So in some way, I've kind of like forgotten what's the more typical workflow that people use. I guess maybe they just check out main, git pull, and go to a new branch. I use Git Fetch most of the time because it does track the new branches. It shows me what was this relayer. So I can see from the last time I ran Git Fetch that there's an update to the main branch, a couple new branches from Andrew, a new one from Justin. There's some new tags. And Git Fetch -p, I think -p is short for prune, tells me which branches no longer exist, and it removes the references from my machine. I guess these are like bytes we're talking about. So it's not so much disk space, but when you use tools like TIG to view all the branches, it's nice to not have the stale junk sitting around. So what I like about Git Fetch is that it doesn't modify anything in my working tree. It just updates Git's local state about what it knows about the origin branch. I forget what the behavior is when you have multiple branches. I think it still defaults to origin, but if you had a fork that you were interested in, I think you'd have to Git Fetch the name of the fork over there. And then Justin said in the comment he has to remove old branches manually. So I don't see any branches. I haven't touched Relayer in a little while since I ran Git Fetch over here. I don't see any of my branches on this list. So this is one of the downsides of the squash and merge approach, is that it's a little bit more complicated to automatically remove your own old branches, because like when I pushed the branch, it had commit ABC, but when I merged it, it was effectively rebased and it had commit DEF. So if you do a plain git branch dash lowercase d, Git will tell you that branch hasn't been merged to main, you probably don't want to delete it. So you could do git branch dash uppercase D to force a delete. So it's a sort of error prone approach there. I think there's a way to script finding out branches that no longer exist on origin and removing your own branches that look the same, but it's a process that I've never really invested in. But anyway, I use Git Fetch. The only time I use Git pull is really I'll git checkout main, Git pull. But most of the time I use Git Fetch to just kind of see what else is happening in the repository. Git Stash Save. I think a lot of people, I'm sure, have run into Git Stash. The typical invocation that you'll see in a cheat sheet or anything is probably just Git Stash. I like to use Git Stash Save and pass in the message, because when you only do Git Stash and you're viewing the stash list later, it'll just say like working tree, name of the branch or something like that. And the message that you provide gives a little more context. Days or a week later, when you're doing Git Stash Show to see what old work that I have in progress, that little note that you left can be really helpful for context, save you a couple minutes down the road. And for anybody who hasn't run into Git Stash, it takes changes that you had but haven't committed yet, and it just kind of puts them on the side. So little sub bullet there. It's probably my most common workflow. I'm like in the middle of some feature work, ran into some kind of flaky test, figured out, oh, okay, needed to just do this couple line change to deflake the test. Let me just stash that feature work that I had in progress, go to a new branch, go commit and push this little test fix, and then switch back to my old branch, git stash pop, and continue on my feature work. There's Git work tree, which is intended to use a single Git repository on disk, but have multiple working trees. I haven't been too thrilled with how that works, and it might be that I've got the wrong like mental model on it, but that is another option potentially worth investigating if you have multiple features that you're working on at the same time that are all longer lived. Gitgrep is another one of my favorites. It works pretty much like it sounds. It's just grep, but it searches through all the files committed to Git, and it does not look at Git ignored files. By default, at least. I'm sure there's a flag to do that. And some of the particular flags that I use with that, Gitgrep -F is for fixed string. So I think if you didn't have the -F for method open paren, it would complain about the unterminated regular expression group or something like that. So, or if you had a dot in there, typically Gitgrep would say dot, that's a regular expression, match any character. But with the -F flag, you're looking for a literal dot. So I use that one a lot. Sometimes you know you're grepping for something that exists in a particular file. I guess probably more often you're looking in a particular directory. And technically you don't need the two dashes separating this, but good habit to get in anyway in case you had a file name with dashes in it. So Gitgrep, after the term you're searching for, you can tell it a directory where you want to look for the files. -w, search for a whole word. So this would find the whole word foo, but not food or fool, other words like that. -I for a case insensitive search. Sometimes you know you're looking for the word clear, let's say, and sometimes clear starts with a lowercase, sometimes it's in the middle of the word, starts with an uppercase C. So case insensitive search can be really helpful for that. And then just like standard grep has -L to only print out the file names, not print out the whole match, sometimes it's nice to just know which files have the word foo in it. So the -L flag, I use that one fairly often.
Hey Mark,
yes.
What's the difference between using Gitgrep and using normal grep?
So Gitgrep will will not inspect files that are Git ignored. That's the big difference. And it implies recursion through your directory, so you don't have to guess whether it's Gitgrep dash lowercase r or dash uppercase r.
Okay. Does the output look pretty similar to like regular grep, or is it like colorized with like Git metadata kind of stuff?
I think it is colorized by default, but that's probably terminal aware. So if you are piping that into another process, it should still just work, but it should also look pretty at the command line.
Gotcha.
And a lot of people have their own favorite. There's AG, the Silver Surfer. People like Grep for grepping through huge directories, and I think a lot of the newer text search utilities probably at least have a flag to be aware of Git ignores, but I use Gitgrep a lot, and yeah, typically in a Git repo, Gitgrep is fast enough. It's more, I think, yeah, Grep is kind of more that case of I just pulled 20 gigs of log lines that I don't want to wait 10 minutes to find my result.
As far as you know, does Gitgrep just use like whatever? Is it kind of like you know how you can like set editor to like Vim or Nano or whatever? Does it use something like that, or is it like does it have grep built into it, or could you use Grep with Git Grep?
That's a good question. I want to say it's just built into Git, but I could see it being actually shelling out to your system grep.
Yeah.
I'm guessing it's built in, but I don't know that for a fact. I guess the reason I would think it is built in is because there are a couple different flags for regular expression flavors in there. So I think it's like Perl compatible by default, but there's one or two other options, which implies that that's built into the Git toolchain there.
Okay.
So that was the end of the ones I use every day. I've got a handful of commands I use occasionally with some helpful flags here. These are kind of loosely categorized without any particular category names. So we've all used git clone to clone a new repo. There's quite a few flags to git clone if you look at the help output. For CI, dash depth equals 1 dash B for single branch main, you can pull down just that single commit. And if you recall back to the Git object model, you're essentially saying, you know, I only need the objects for this particular commit, and that can save you some time if you're on a slow bandwidth connection, or if it's a gigantic repository and you don't want to wait for it to be downloaded, such as if you're running on CI. It's nice to be able to clone only the objects that you're actually going to use. A few history-related ones. Git bisect is a really powerful Git tool. So if you know that a particular piece of behavior changed between two commits, typically you're looking for where a bug was introduced. Occasionally it is actually a bug that's been fixed that maybe you didn't expect a behavior change, or it's just something started working differently from when it did before. You know, it's easy if you're working in that code base and you're like, I know it worked right yesterday and today it doesn't. There's only 2 or 3 commits to look through, but this is more a case of like, I haven't looked at this functionality for months, and I know the 2.0 release worked right, but the 2.7 that I'm running now doesn't work right. Git bisect will do a binary search through the commit history. Well, it'll help you do a binary search through the commit history to find where the behavior changed. And so you can run it pretty manually, but there's a git bisect run subcommand where you give it a script where you could run unit tests and see when tests stopped passing or when they started passing. You could just provide a helper script that, you know, runs a particular command with a particular flag, and Git bisect will just run it, look at the exit codes, and it'll tell you which commit was the one where the behavior changed. It's really really powerful tool for finding when something changed. Git Log, something that probably a lot of people have used in some format. When you just do Git Log, it gives you a short summary of commit messages in chronological, well, in commit order, I should say. There's a -- format flag, which is pretty helpful. Sometimes you just want to print out like the short hash and an author, maybe just the title of the commit. There's a lot of different flags for the format. --S flag, if you know that there was a particular commit that, if you're looking for a commit that added a particular new method and you have the method name, --S will only show you commits that added or removed that particular text content. So that could be helpful in finding the history for something you're interested in. And you can also use Git Log and provide a path to just see the history for a particular directory or a particular file. Git blame is very handy. Chances are your editor or your IDE has integration for Git blame. It just shows you a line by line what's the Git commit that introduced this line and who is the author. So sometimes you're like, oh, I don't recognize this. Oh, okay, somebody added it last week. Totally new. That's why I didn't see it before. Or maybe something's kind of questionable, so you want to go figure out who to talk to learn more about it. Git blame is a quick answer, and in fact, you do have Git blame from the GitHub UI as well, but it's there on the command line too. Git Show, every once in a while I have to reach for this. I guess it's fairly uncommon, but you can show the content of a particular file from a given Git commit. So if you were like, I don't know, if you wanted to see the README for a previous release, you could do git show v2.0.0:readme.md, and that would just cat out the content of the README for that particular release. I guess usually you'd be looking at source code, but just as an example there. Some commit modifying ones. Git revert is the undo of a commit. Comes in handy sometimes. Cherry pick is like a little bit like a rebase. You're just taking a single commit and adding it on top of your current branch. Git branch -m. A lot of times I will check out a new branch and give it a name, and I get partway or most way through my work, and I'm like, yeah, this branch name doesn't reflect what I actually did. Git branch -m will just change the name of the current branch, as opposed to checking out a new branch with a new name, deleting the old branch. That one's handy.
Can I ask you a question about cherry pick?
Yes.
So cherry pick versus merge. So so you're saying cherry pick will let you take a commit from somewhere else and it basically merges it into your branch, versus merge is for the entire branch. It's not for like a commit.
Yeah. So it does not create a merge commit. So it so cherry pick will take an argument of a single commit. I think you probably can do multiple in one command line, but usually you're only referencing a single commit. So Git will look at what change was introduced in that commit, and it will essentially apply that diff of that commit on your current branch, and it will copy over the commit message and author details from that commit. And that new commit will have one parent, which is the newest commit, or the current commit of your current branch, I should say. So it doesn't introduce a merge commit.
So it's that commit versus like the main branch. So like say that they added 4 lines, but you were on a feature branch, you'd just be bringing those 4 lines into your feature branch, or would it take into account like what's different between your feature and main as well?
It would only be the 4 lines from that commit in that example.
Okay, gotcha.
Yeah, I think my use case for this is often, again, there's a few branches with work in progress. It might be a branch that I authored, or it might be somebody else's change that I want to just locally integrate. I may not even push it. Cherry pick is just a quick command to say, take the commit from that branch and bring it over here. I mean, I guess in that case you could use merge, but sometimes I use cherry pick. It just kind of depends on context. Git ls files is another handy one occasionally. That will just print out a list of all the files that Git is tracking in a repository. So sometimes, like, I remember the file is named foo.go, but there's a lot of directories here. I don't remember where it was. git ls files, pipe it in grep, and I can see where that file is. Or sometimes I might be asking a question of like, how many test files do we have? You could grep and pipe it in wc. Example use case. Git Ref Log is a really handy tool. It tells you the history of as you've created commits, as you have switched between branches, it'll have the actual SHA of the commits that you've worked on. So it could be that you had you were working on a branch, you like went through a bad rebase, you lost your commit. You can use Ref Log to find the old SHA that you were on and recover the changes there. Once in a while, I'll run git gc -- aggressive locally. Even though Git will automatically run its garbage collector, I think it like runs it once every 1,000 or every 200 commits, something like that. But it's like, I don't know, if I got 10 seconds and I'm not doing anything else and it just occurs to me, I might run git gc aggressive. And for large repositories, if you look at how much disk space your .git repo is consuming, it's pretty common, honestly, to see like a 10 or 100 megabyte disk savings after that. So like, even though we are probably running on machines with plenty of space to spare, I'll run it sometimes. It's just kind of fun to see some disk saving after using a lot of CPU. Had a couple of screenshots earlier of TIG, but sometimes I'll look at TIG. It's just a nice visualization of what's happening in the Git repo. Not a whole lot to say there. You can brew install it. It's just helpful to get a quick look into history. I double checked today. The only aliases I use, git checkout, CO, ST, shorthand for status, and I alias grpe to grep because that's probably my most common typo. And then I don't have to go back and hit back a few times, switch letters.
That's a good one. I think I'm going to steal that grpe one. I do that all the time.
Happens to me multiple times a day. But I don't know, for what it's worth, yeah, I've been using Git for something like 13 years. And I know a lot of people do set up aliases for like, oh, git pull and git push origin master or whatever. Like, I just don't do any of those. I type things out longhand, and partially that's because I type fast enough that it doesn't actually slow me down. Part of it is that if I'm trying to reproduce something, it's nice to be able to copy my command and paste it somewhere and know that anybody else could just run the same thing and they don't have to worry about like some obscure alias. And for those kinds of potentially destructive operations, such as git push or force push, for me, typing it out beforehand is a nice double check that I'm doing what I actually intend to do. Not to say that I've never hit up a couple times and then hit enter and then found out that I force pushed over a branch that I didn't mean to force push. Like, I'll still do that, but generally I type things out. I think this is my last slide. So what I don't like about Git, honestly, I really like Git overall. Work trees that I mentioned earlier, I feel like maybe I just misunderstood their intent, but I wanted to like just use a work tree and just have a separate directory for a feature branch, go do some work, commit it, and then just get rid of the work tree easily. But it ended up being like, it's coupled with a branch and you can't just delete the branch and have the work tree go away. So it's probably that I don't understand it the right way, but I don't know. Wasn't happy with work trees, but it's been at least a year since I tried it, so it might be better. The main thing I don't like about Git is GitHub. There's a lot to like about GitHub. GitHub works great for what it is, but some of the more specifics. So like if there's some rare circumstances at my last job with like wanting to do a shallow clone, we had a pretty large repository and I only wanted to clone a single directory, but like that was something that you have to enable on the Git server, which of course you can't do that for GitHub. And I don't know why they didn't have that enabled, but like if I were running my own Git server, it would be a one-line config change and CI would have been even faster, and we really cared about that. So you just don't control what they're running. You can't just simply add a feature because it's not open source. Obviously, GitHub wants your money. It's nice to do things for free when it makes sense. But the vendor lock-in is what kind of bothers me the most about GitHub. And as they go through pricing changes and like it used to cost this many dollars a month per user in your org, and now it's going to be twice that or whatever. Like, you get so coupled into GitHub that all your issues, all your pull requests are there. If you wanted to migrate to something else, like I'm sure GitLab has a nice migration tool, but it just ends up really awkward in your Git history then that you're like, oh, fixes issue number 100. And then one day you might not be on GitHub anymore, and that issue number 100 doesn't exist anymore, and nobody can just click through to go see what the detail was there. So turns out there is at least one other source control tool out there. Fossil is from the folks behind SQLite, and back from the beginning of the talk here, source control is just a database. You got files and directories, and you got commits. That's basically all it takes. So Fossil is a source control system. I haven't really used it, but I would love to try it out sometime in earnest. And Fossil also tracks your issues. They've got wikis and stuff built in. And so it's like the whole project history, not just your source control, but the whole project history in one database file, which is really cool. I could see some use cases there. And of course there's trade-off there that, like, if you have external contributors who are expecting GitHub, it's a major ask to say, like, oh no, go to our like fossil.mycompany.com and go make an account there, and there's overhead, but it's interesting to know that other people have thought about and invested pretty heavily in a completely standalone project management source control tool on a very proven technology. So technically I only booked till 3:50. It's 3:55. I've got time the rest of the day. Happy to go into any more questions, revisit any topics, but floor is open.
Yeah, I had one more. Do you have any thoughts on like third-party tools like Git Lens, Git Kraken? Do you find that those are helpful tools to incorporate in, or more like handicaps that prevent you from really understanding how stuff works?
It probably is a little bit of both. I feel like it would be easy to get started. So like if you had never used Git, if you've never really used source control, you're a new engineer, some of those UIs, and just to be clear, I don't know anything about those particular tools that you mentioned, but I'm assuming those are like graphical interfaces on top of Git. I think those are probably really helpful in getting started, but it's probably possible, it might not be easy, but I'm sure it's possible to get into some of those other weird Git states where you've got this botched rebase and you can't easily get out of it. You've force pushed away, you've rebased away a commit that was actually really important, and it's not trivial to get it back. Nothing wrong, especially when you're working in a company with enough people who have experience, nothing wrong with just asking for help in that kind of situation. But I could see where you could potentially end up in a jam, and then you're at the unfortunate circumstance of, I don't know how to use Git from the command line, and now I need to learn it to get myself out of this hole I've dug. So, like, personally, I try to avoid using those kinds of tools, but I don't necessarily have a negative opinion of them. Like, they have their use, they have their place. They're just not my personal preference.
Okay, got it.
I've got a question. How do you usually handle conflicts? Like, so for a while I was mostly just merging, like before I would get a PR up, and I would kind of handle them in the GitHub UI, which isn't the greatest. I've started to kind of lean into more just using the command line for Git, but also not an elegant solution, because then it like forces me into, like a terminal based editor, and I haven't quite figured out how to like throw it at something like Sublime or anything yet.
Yeah, so when I'm running into merge conflicts, I will handle them all manually in the editor. I could probably come up with like a good 15, 20-minute talk just on going through that process. What I tend to do is usually, see David, usually you're going to have some number of conflicts. Like usually it's going to be, if you got one or two, it's really easy to just like, oh, say, yeah, obviously like the top one is what I want or the bottom one is what I want. You've got a handful more than that. It's like pretty consistently, I'm taking the top line, except I changed one character. So I'll copy out the top one and I'll change X to Y. I'll rename this variable, whatever. But as you get into these like 30-line conflicts where I rewrote half this method, you rewrote half the method, and Git doesn't know how to combine them together, then for me, it ends up being a very involved, like, I will literally go through line by line. So you're going to have like, they changed 30 lines, we changed 30 lines. I will like literally go line by line. I'll say like the first one was like, I added a new parameter to this function. You added a new parameter to this function. I'm going to take that line out of each. I'm going to rewrite the proper function signature outside of the conflict block. And then I'm going to continue going through line by line until there is like nothing left. So those are kind of your worst case where you actually have to really be manually involved. But most of the time, I think it's a clear, like, it's just one or the other. I'm just taking the code and my changes overrode theirs or theirs overrode mine. But beyond that, I don't know that I could really prescribe this is how to deal with conflicts. But hopefully that was the answer. I just use the editor.
When you say you use your editor, like you have it set up to where like when you end up with having to deal with merge conflicts, it opens it up in like VS Code or something for you.
No. So I'll run git merge origin/main. So I'll do git fetch to make sure my origin main reference is up to date. Git merge origin/main, and then it'll say like, oh, successfully merged a.text, b.text, but c.go had a conflict. And so then in my git status, if I run git status again after that, it'll say like conflict needs resolved, c.go. So at that point, I will just manually open Vim against c.go, and I'll see the conflict markers, bunch of less thans and greater thans. Like that, typically that'll be my first thing. I'll just slash less than, less than, less than, go find where in the file the first conflict is, and just start hand editing the file until one side of the conflict block is empty, and then manually deleting the conflict open, split, and end markers.
Cool. That's definitely helpful.
Nice.
I think you can set like an environment variable called editor, and for example, use like code or Sublime or whatever editor, and then when you do the def or the merge, then Git uses that.
I was trying to figure out how to make it lean into something more high end, because like I figured out how to switch it from Vim to Nano, but I couldn't get it to like actually open up an IDE or text editor, which I'm sure is something that I'm doing wrong.
I think, yeah, North's point is right. Yeah, editor, if you have your editor environment variable set, it should use that. If you have git_editor set, it should use that first as precedent over just plain editor. But it should use those for when
maybe
that's
maybe that's the nuance. Actually, I don't know if I was like doing the kind of one with the higher precedence.
That could explain it.
Could always just alias Vim to code.
Risky move there. All right, so we're a couple minutes past 4 o'clock. Thanks everyone for making it. And I'll be sharing the recording and slides in a couple minutes once the recording is uploaded and everything. And always feel free to reach out. Been using Git for a long time, kind of seen everything there, and happy to help wherever it makes sense.